This morning we're going to learn a little bit about TABLOCK versus TABLOCKX versus just normal processing. And the first thing I'm going to do here is I'm going to fire away a query, and I'm going to use it with an insert. Now, one thing I want to note is that when it comes to TABLOCK versus TABLOCKX versus normal processes, your environment is going to first determine everything, right? If you're in an OLTP environment, I actually would not recommend either of these. That would be a very bad idea. Now, if you're in an OLAP environment, one of these may be actually fairly useful. So I'm going to demonstrate TABLOCKX versus a normal process just to show you the speed. And I've done testing with this probably about, I would say, 30 or 40 times. Just in the last few days to test. What we're doing is sending huge sums of data across servers, or not across servers, I'm sorry, across databases, and so we were testing the speed. But in general, TABLOCKX versus normal process is going to be a lot faster. Now, the way that TABLOCKX works in terms of TABLOCKX versus TABLOCK is that TABLOCK is going to basically grab well, that's not the right word. It's going to essentially use whatever you've set. So when you set your transaction isolation level to, let's say, read committed, read uncommitted, etc., TABLOCK is going to use that. Now, that doesn't mean that if you sit there and delete data and someone tries to insert data at the same time, you're going to be able to do all kinds of processes at the same time. Because, again, individual transactions, for instance, inserts or deletes, may have their own isolation level. So it's not going to trump what SQL Server is designed to. SQL Server is not designed to be handing out bad or inconsistent data. So, you know, and you could try it yourself. You could try to throw a transaction where you're deleting from a table and at the same time someone's deleting, be inserting data, and you'll see some very interesting things. Of course, it has to be long enough to where they can run into each other. And then we have TABLOCKX is going to grab exclusive locks, basically. It's going to grab onto whatever the table is, and it's going to be exclusive. And the purpose is, or one of the things that we can use it for, especially when we're inserting, in this case, we're inserting, I believe, 1.4 million rows of data. It's very useful in this case for speeding up the performance, as we'll see. So the very first query, the execution time 0 milliseconds, elapsed time 0 milliseconds, but we have CPU time now 3200 milliseconds and 2100 milliseconds for the elapsed time. When we go down to the second query, we only have CPU time at 800 milliseconds and elapsed time at 4900 milliseconds. So we can see that there's significantly less time for the first as there is for the second. And when we're talking about billions of rows of data in the case of yesterday, and that I was doing just on testing, it's even, I mean, it's geometric. It's not a linear thing. We're not gaining linearly. We're gaining on a geometric scale, so it's going to start paying off. So what this does right here is this is grabbing an exclusive lock on this table. It's saying, you know, nothing can touch this table, and I'm going to insert these data. So you can see that this does affect performance. Now, that doesn't seem like a big deal, but if you're transferring, let's say, you're doing a C# loop, and every loop around one database is hitting another database with 1 billion rows, you can see that TABLOCKX, in the case of what we were doing, it was a difference of, let's see, 50,000. Well, that wasn't the billion row one, but there was about 50,000 millisecond difference. And that was like 100 or 120 million. And again, we can call this, and I always say, like, you know, what you should do when in testing is, you know, call your processes 3 different times at least, and that way you start getting a feel for how things work. But you'll see that there are going to be similar numbers each time I call this. So it's important to understand that TABLOCK is going to go along with however you've set it up. Again, if you've set it up as read committed or read uncommitted, it's going to use however you've set it up. Okay. If you're using TABLOCKX, it's going to use an exclusive lock. Okay, let's look at this again. So we have, again, about 3,000 milliseconds for CPU time, 2,100 milliseconds for elapsed time, and then we come down here and now we're at 700 milliseconds and 4,300 milliseconds. And what we're seeing, and the times will change because of other processes that are going on, but what we will see consistently time and time again is that this query, the second query here with TABLOCKX, is going to be faster than the above query as far as the elapsed in CPU time. That's going to consistently come back. So these are some notes to make about TABLOCK versus TABLOCKX versus normal processes. Again, I would not recommend TABLOCKX in an OLTP environment. You definitely want to make sure that that's going to be right for the process, but in many of the OLTP clients that I've worked with, and in many of the OLTP environments that I've worked in, using TABLOCKX on a production server, that is, I should say, would be very, very careless. So that's not something that I would recommend using. But it is something that I would definitely investigate as far as an OLAP environment when we have huge sums of data that are being inserted. As you see, one is, from a total perspective of elapsed time, one is about 5 times faster than the other.